I started my life as an engineer actually when I was 13, building different things in electronics. I was fascinated by it, building different gadgets and actually trying to sell them.
Welcome to 20-Minute Leaders. Just sit back, relax, and learn from the leaders of today. It's a journey. Each one is different, unique, inspiring. Let's get started. 20-Minute Leaders is a proud supporter of Make-A-Wish Israel and Tech to Peace, and is in proud collaboration with Secret Chord Ventures, J Ventures, Riverside FM, Fusion VC, Birthright Excel, J Impact, Leap, Google for Startups, and Hippo, and in media partnership with C-Tech. Welcome to 20-Minute Leaders. This episode is very special on deep technology and a very, very cool startup. Please meet Raviv Melamed. Prior to founding Vayyar, Raviv was vice president of the Intel Architecture Group and general manager of Intel's worldwide mobile wireless group. He joined Intel in 2004 as part of Intel's acquisition of Envara, a fabless semiconductor company based in Israel, where he served as vice president of R&D. Prior to this, he held several roles in the Israel Defense Force in the field of large-scale radar and communication projects. Raviv holds a BSc and an MSc in electrical engineering from Ben-Gurion University, Israel. Raviv Melamed, welcome to 20-Minute Leaders. Thank you so much for joining me. How are you?
Good. All good. Thank you.
Thank you very much for joining me. It's 10 p.m. in Nest Zion, where you're calling from, and I very much appreciate your time. And I even more than that appreciate the amazing work that you're doing with Vayyar and 4D radar imaging. And I can only imagine or start to imagine the different implications this can have on our world and our day-to-day and the ripple effect that this makes in the industry. But your journey started long before that. It started joining Intel for an acquisition where you were VP R&D at your previous startup. Tell me a little bit about yourself, Raviv. How do you sort of look at your own path and entrepreneur, or who are you?
Who am I? It's a short question and a long answer, but I still need to find out. So can't tell you that yet. But I started my life as an engineer actually when I was 13, building different things in electronics. I was fascinated by it, building different gadgets and actually trying to sell them, different kits. Back then it was you could actually build things with your hands. It wasn't like chips and things like that. So that kind of started the whole thing. And then in the army, I was doing more complex systems. Then went to a startup, and then a startup that was acquired by Intel, and then developed myself in Intel to become VP and GM of the wireless group there. And then another startup called Vayyar.
And just I think a month ago, you announced that Vayyar achieved unicorn status with over $100 million in fresh funding, looking at 4D radar imaging. But looking back for a second, we had a short conversation just recently about your work within Intel. And it was really interesting to hear how you came in to an underperforming product or vertical within Intel and managed to through leadership turn things around. Tell me a little bit about what happened there and what you learned from that experience going into Vayyar.
Yeah, so I think in Intel, I've learned a lot, especially about how big organizations work and what happens to an organization, at a later stage of its life, let's call it, how you kind of form a way of thinking and how bureaucracy and not really understanding the values creates, a huge gorilla that can't really move fast and basically missing things sometimes, right? So obviously Intel is a great company. They do great things. But a lot of it is based on the inertia and trying to go into new markets that requires different sets of capabilities, I would say, and, the ability to give freedom to people to go and operate but not just try it, but really take it all the way through, and not just throwing money at it, just really taking a real risk, right? So I think that's something that you've learned in your years as a corporate. What my teammate and I did is basically doing everything differently compared to what was done before. Not moving, not doing things on Intel fabs, moving outside of Intel to TSMC, for example, or changing cost structures, things like that. So there are a lot of things that I've learned over there. I'm really thankful for Intel to allow me to do that. Obviously, it was beneficial for Intel too, but that's kind of what I learned there.
And I think you're being very, very humble with the different things that you've done over there. But we'll leave that to another conversation, because I want to focus on Vayyar. Mm-hmm. Take me back 11 years ago. You're after 6 years of being at Intel. You're leaving as vice president. You're about to embark on a new journey in the deep tech space, 4D radar imagery. What is the problem that you're observing in the world, and where are you at with this problem?
Yeah, so I think, once I decided to leave Intel, I started to think about what's the next thing that I want to do. And I started to look at the market, and for me, there were like three routes. One, continuing with communication, which I did for many, many years, and I really didn't find it interesting. The second one, back then, homeland security was a big thing. I did that for part of it in the army, so again, wasn't interesting. And the market that was interesting for me was the medical market, because that was something that I didn't do before, and I thought that I'll be able to do good things, and, my knowledge, etc. And it was really kind of intriguing to go to that path. So we started thinking about that, right? And I wanted to see if I could do something else, something new. One of the things I learned over time is that, and that's not mine, I mean, other people said that, is when you want to really create innovation in certain markets, the interesting thing is that you can bring technologies from a different market to that market, that suddenly good things happen. That's kind of what happened over here. So one of the things that I was asking myself is, why can't I use radio wave kind of frequencies to look into the human body? And that was based on something that I did in the past in the army, that looked into walls with the radio waves. I started to kind of check if that can be done, what people did in the past, which is very important. And I found out that they all got to the same kind of issue, which was the cost of the systems, because radio waves were extremely expensive to do. And I think, like every new thing, it's kind of everything kind of falls at the same time to the right places. The technology is there, the idea is there, and at that time, MIMO radar basically just kind of really started. I mean, people started to write more articles, so that was one thing. MIMO radars are multiple channels that you need in order to get better resolution. So MIMO radar was just at the beginning of it. And then silicon was just starting to become very cheap for RF. So what I did in Intel, for example, was MIMO basically for wireless, right? So when I looked at all those articles and look at what people did in the past, I say, hey, if you use silicon, if you come with silicon concepts to this problem, then you can actually create imaging. And that was the moment I was like, oh, okay, we have something here. Now let's see what we can do with it, which market is the right market, etc. And breast cancer imaging was the right market for that to start with.
By the way, Raviv, just to set the picture here, you're sitting and you're looking at this technology emerging. You're looking at the market. You understand that there's a timing. You understand that there's knowledge that you have, a team of great people that you can form to this. when you're imagining the world with with this technology, with the new devices, what opportunities does it allow for the world in general with better imaging and better use of these radio waves? What can we do potentially? Why is this interesting?
Yeah. So when we started, it started with with breast cancer imaging, but we quickly understood that the same sensor can be used to multiple markets. That's what we do today. There's a whole philosophy of why we're doing it this way, but we're not gonna talk about it right now. So when you look at basically 4D imaging, call it 4D because the fourth dimension is movement and speed. But the moment you have a sensor that can see through things with high resolution, that can see in every environmental condition, and it's very low cost, then there's multiple applications, right? It's basically kind of having a Superman vision at low cost, right? That's kind of it. Once you have Superman vision, you can imagine what you can do with it, right? Whatever you do with optical, there's multiple applications that you can use it for. Looking inside walls, looking inside human body, tracking people, tracking objects, etc. So that opens up a whole new set of applications in a new modality. So that was the idea. That's how we started. And that's the first slide we showed to our investors, like using one sensor to multiple markets.
Mm-hmm. So when you start with breast cancer, and what happens?
So we started with breast cancer. Actually, we started in parallel with 2 or 3 applications. And we pitched 4 applications because we knew that each one of them will take time, and it's not an easy thing to do medical. So we understood that we need to run in parallel, which was very unusual at that time. Today, people are more kind of open to it. But back then, people explained to us that we need to focus and all of that stuff, which is true to many other things, but not specifically to sensors. And we started parallel in earwall imaging, testing, breast cancer imaging, and also imaging in mass production of food, to detect contaminated things like that.
Interesting.
So these were kind of 4 different applications that we're running in parallel. And since then, we added several more applications like automotive, elderly care, etc., etc.
Now, in the beginning of this conversation, you mentioned that one of the things that you took with you from sort of corporate world was this idea of autonomy and really supporting new verticals or new domains within an organization, even. And it's beyond just the money, it's actual support and seeing it through end to end. Is that sort of what we're seeing here? With you mentioning that we're doing things simultaneously, and how do you as a CEO, what do you actively do to make that a reality within your organization?
Yeah, so first of all, it starts with the structure of the organization. So if you look at typical organizations, you have CTO organizations, but what you find out over time is that the CTO organization, dealing with things like, 10 years from now, 15 years from now, and then you got the BUs. They live the day to day. They need to deliver. They need to solve the problems today, not in 10 years. And there's always a gap between these ones. And nothing that is the CEO comes, but not nothing, but a lot of the things that CTO do, when they come to the BU is like, now you're like totally not related to our architecture. You're not related to the way we do things. You're not related to the market, which is the biggest problem usually, etc. So what we've created is an organization that is self-contained, that can bring innovation, but that innovation is market-driven innovation. It's not something that, we're not research. We're trying to solve the next problems, right? And this is like, think about it as a filter. If BD comes with the market, since that's the market, then come and talk to the customers, and we're doing proof of concepts in that organization. So they're kind of cleaning up the stuff that doesn't work and leaving the ones that work. And there is a customer in the market behind it. Okay. And once that happens, then we know we're kind of vetting this, then we know moving it into the R&D stage. and then developing that new market, right? So it's always market-driven decisions, and it's moving very, very fast, and we fail fast. Okay, and that's super important because those POCs allow us to, do something, doesn't work, throw it away. We don't invest too much time and effort in it. It's not a big deal until you find the right, thing that you need to really focus because you have a proof for the market, proof to the technology, just like a startup, and you make it bigger. So that's kind of the mindset. By the way, this is exactly how automotive started in Vayyar, exactly how elderly care started in Vayyar.
Wow.
Through that process.
And generally, are those verticals entering bottom up, top down? Who's sort of the champion of these new verticals that are coming into Vayyar and emerging? Because I'm guessing that for every success, there must have been a few failures. So you've tested a lot.
Yeah, I mean, there's several failures, but the way it's done, it's done in, it can be bottom up or top down. It doesn't really matter at the end of the day. So this morning, a guy sent me, one of our employees sent me, I have a new idea for Vayyar. Can we talk? I said, sure. 30 minutes, let's hear his idea. And the first step of his idea is to go and check it out in the market, right? So the BD guys will go and check it, see if there's something about it. If there is, a customer is paying for a POC, that will go to the next step. And if the customer will pay for a project, that's probably gonna go to the end of the road. So that's how we do it. So it doesn't matter who brings the idea. At the end of the day, if it's a good idea, it will survive.
I love it. Tell me a little bit about, what are different interesting use cases for Vayyar in the real world, right? For non-deep techs that don't necessarily understand the technology here, how is Vayyar positioned to change the way that we as humans interact with the world around us? We mentioned, breast cancer, automotive, elderly care, but what tangibly, how are things changing?
So let's take elderly care as an example. Is that okay?
Of course. I love that. Yeah.
So elderly care is a simple example where today there's so many old people in their homes and you have no clue what's going on, right? So there's a very interesting psychological element here, which it's interesting to talk about. Like, for example, you have parents, probably, how old are they? 60?
65, 64, yeah.
Right. And you think that your parents will live forever, right?
Of course they will.
That's how your mind thinks. Exactly. And your parents will always be healthy and all of that stuff. And actually your brain refused to understand the fact that they're actually getting older, getting weaker, etc. So that's one path. The second path is they always look at you as their son, and they don't want you to know what's going on with them, right? So actually the certain age, 75, 78, 80, they're starting to fall, but you don't know about it because they're not going to tell you, and you don't even start to think that they're falling. Okay. And then comes the big fall. Okay. The big fall is a fall that they cannot hide anymore. Okay. And then that thing suddenly switches, right? Then you start to really, really be worried about them. And they're like, no, it's okay. And you need to find some kind of a balance where you know that they are okay, but you still keep their dignity. You still keep their respect to them and all of that. Now, you're not going to put cameras in your parents' bedroom or bathroom, right? But you will put a sensor that keeps their privacy, but monitor them in a way that if there is a fall, you will know about it, right? You or they know about each other, right? But someone knows. So that's the first step. The second step is even more interesting. So the second step talks about preventive medicine. And preventive medicine means that you track a person over time and compare data. Now, there's no single sensor today that can do that in the home. So when you think about it, talk about old people, they're in the home all the time. So if you had a sensor that keeps privacy from one hand, no pictures, no something that tells anybody that's me, right? But I still get the data and I can analyze and alert. Then super important. Two examples I give you. One, an elderly care facility that we are tracking. A person we found out that is sitting on the sofa more and more time. right? And the medical team was alerted. They checked the guy and they found out that he has heart issues.
Wow.
So basically, that's classical preventive medicine, right? Another case was with a woman that lost her husband. And they found out that the device basically alerted them that that lady is staying in bed longer and longer. Basically, she was kind of getting into depression. Again, send the medical team. She was getting into depression. And obviously, they took care of her. So when you started to look at these issues, there's tons of them, right? For example, there's a clear correlation of deterioration of your health when kind of in correlation with how many times you go to the toilet at night. So you don't know anything about your dad, but when you suddenly see that suddenly he's going to the toilet more and more at night, that's a clear indication there is something there. So he better get checked now, right? So there is a very interesting balance. He wouldn't even know that. He wouldn't even track it. He wouldn't even be aware of it.
Right.
And that's going to change people's lives dramatically, right?
I love how we started the conversation talking about wireless communication to breast cancer to a little bit about, the technological piece of it. But then we're going all the way back to the human computer interaction. And it's not just, breast cancer and imaging, but we're actually talking about behavioral imaging and being able to sense things that, if we are just able to observe them in a sort of an unobserved world today, they can have so many non-direct implications that, if you were to ask me, how to predict what are the different behaviors that a person may have that indicate there's some specific issue. I think that's fascinating. And Raviv, thank you so much for spending this time with me. It's inspiring what you're doing with Vayyar. I think that the structure of allowing for ideas to rise and to innovate all the way to the end of the cycle where they are full-blown verticals within Vayyar is awesome. Congratulations again on the wonderful news. And thank you very, very much.
Thank you. And keep doing the great job you're doing.
Thank you. Thank you.